Welcome to the answer video of the chocolate sprinkles question. My name is Sharon and during this video I will explain you how you could calculate the outlet temperature of the chocolate that needed to be heated up. Here you see a sketch of the situation. The chocolate is flowing into the tube of which the wall has a temperature of 100 degrees Celsius to heat up the chocolate, which has an initial temperature of 20 degrees Celsius. The situation is steady state and I have already written down the rest of the data that was given. The first question was to determine whether the flow is laminar or turbulent in this situation. Of course, you can determine this by using Reynolds number. But first we need to calculate the velocity of the chocolate flow by using the mass flow of the chocolate. Then we will find a velocity of 0.24 meter per second. Reynolds number in this situation is 1.27, so the flow is laminar because Reynolds number is very low. The next question asks you to determine the average outlet temperature when Gratz number is above 0.1. Before you can calculate this, you need to set up an energy balance over a small piece of the tube, dx. In this situation, there is inflow, outflow and production of heat. The inflow is just the intern heat of the chocolate that enters the tube at point X. And the outflow, the intern heat of the chocolate that leaves the tube at point X plus dx, which you can describe with the temperature times the specific heat times the mass flow. The heat that is produced is caused by the heat of the wall that transfers to the chocolate, which is called VQ. The mass flow can be described as the volume flow times the density, and using Newton's law gives the following equation. Besides, the inlet and outlet of heat enters through the surface area of the tube, which is 1/4 P squared D, and the heat of the wall that enters the tube is transferred to this area, which is P d times the small length dx. Delta T is of course the wall temperature minus the temperature of the chocolate itself. This brings us to this equation. Separating some values out gives our differential equation. Solving this equation gives one constant. By using the boundary condition that at x is 0, the temperature is the initial temperature, which is 20 degrees Celsius, we can determine that C1 equals this. So, the final equation for the temperature is the following equation. Now we need to determine the heat transfer coefficient H. Because the flow is laminar and Gratz number is above 0.1, Nusselt number is 3.66. So also the heat transfer coefficient is 3.66 because the diameter and the thermal conductivity coefficients are the same. Filling in the length of the tube of 50 meters and separating the T of the chocolate out gives us an outlet temperature of the chocolate of 20.6 degrees Celsius. So the chocolate is not warmed up very much. This is because the flow is just laminar. If we assume the flow to be turbulent, the situation will be different because Nusselt number will change. With a Reynolds number of 30,000, so turbulent flow, and a Prandtl number of 7.5, we will find a Nusselt number of 202. When filling in this in the overall equation for the temperature as a function of the place in the tube, we will find at 50 meters the outlet temperature to be 46.2 degrees Celsius. So this is much more. The last part states what if temperature gradient from the wall to the middle of the pipe also results in a viscosity gradient. Then the Sitter and Tate correction needs to be taken into account, which results for turbulent flows for this Nusselt relation. Here you see the viscosity difference of the chocolate at different temperatures. The viscosity decreases when the temperature increases. The question is, at which x, so which position, in the pipeline is then the average temperature 30 degrees Celsius when we assume the rest of the given constant to be independent of the temperature? By using the new Nusselt relation, we will find a Nusselt number of 208, where the viscosity of the wall is equal to the viscosity at 100 degrees Celsius, because that is the temperature of the wall, so of the chocolate near the wall. And using this, we will find that at x is 16.33 meters, the temperature of the chocolate in the tube is 30 degrees Celsius. Thank you for watching this video. If you still have questions, you can post them on the forum. Then we or other students will answer your question.